So we're looking at the complex number system, and the complex number system starts with the natural numbers. So if you're watching this at home, you can follow along with complex number systems in Unit 1. This is the notes. So we start off with just the natural numbers. So we have that little box. So our natural numbers, does anybody have an idea of what the natural numbers are? Think about if you're out in nature, how many apples are in a tree? How would you do that? How would you know how many apples are in a tree? You'd count them. So what do we start with when we count? 1. So our natural numbers are 1, 2, 3, and so on. Okay? So then our next level that's included is our whole numbers. So our whole numbers is one step up from our natural numbers. So what do you think we'd include with our whole numbers? 0. So our whole numbers are 0, 1, 2, 3, so on. Okay. Now what about integers? Again, getting a little bit bigger. It's going to include our whole numbers and our natural numbers. Negatives. -2, -1, 0, 1, 2. Then we have our rational numbers. So that's going to include all of those. We've got integers going all the way to the negatives, all the way to the positives. What's going to be the next step above that? Decimals, right? And so what makes a rational number is we have like 0.25. So they end, they come to a conclusion, okay? You can also think of it as 1/4 would be a rational number, right? It's the same as that 0.25. So we have our decimals, we have our ending fractions. So before we go into all of the real, let's look at our irrationals. If rationals come to an end, they close, what do you think our irrational functions are going to do? Our real irrational numbers. So again, our rational numbers close, they stop. What do you think our irrational numbers will do? Non-stop. They're never going to stop, right? So those are our numbers like pi. So our numbers just keep repeating. They have decimals that just keep going and going and going. So they're repeating decimals. So we would say like pi, 1/3, square root of 2. These numbers are going to keep going. They're never going to well, actually, I guess 1/3 is not technically 1 because it's a repeating decimal. Irrationals are ones that will continuously change. They don't have a repeating decimal. Because a repeating decimal, then we can kind of round it. So we got pi, square root of 2. Our real numbers are any combination of both of these. Okay, so our real encompass both our rational and our irrational. So that leaves us with our other box on the outside, our imaginary. So these are all included in the real. So we have our imaginary, that's its own little box. And we'll deal with some imaginary numbers later. Does anybody know what we annotate imaginary numbers with? If we had to use a letter, what do you think we would use?
S.
Not an S, an I. Right? So our imaginaries are I. And the way we get imaginary numbers is we take the square root of a negative number. So anything that has a negative underneath the square root is an imaginary number. And so all of our real plus our imaginary make up our complex number system. Okay. So the way we can combine those is whenever we write them down, we'll put our real number first. So we can say 4, and then we'd say plus or minus whatever our imaginary number is. So we can say 4 plus 5i is the correct way that we would say we have a complex number. You can have just the real, you can have just the imaginary, or you can have them combined with addition or subtraction. And then you have your imaginary number with it. So 4 plus 5i would be our complex number. Okay? So let's look at the bottom of that page. So it says determine the following statements are always true, sometimes true, or never true. So determine if a number is a rational number, then it is a real number. So the easy way to think about this is if this one's true, this is going to be on the inside of it. So is the real number inside of our rational numbers? Is that always going to be true, sometimes true, or never true? If we're a real number, are we a rational number? Or is a rational number, if it is a rational number, then it is a real number. I read it backwards. So is a rational number always going to be inside the real box? Yes. So this one is always true. Okay? Doesn't matter what rational number we choose, it's inside the bigger box of being real. So number 2, if a number is a real number, then it is a complex number.
Would that be sometimes true?
You would think that, right? Because a real is just half of the complex number, but it's always going to be true, okay? So if we look at our notes again, we have that entire circle is the complex numbers, and the real is inside that big circle, okay? So it's a good thought, but you can have a complex number if you just have the real or if you just have the imaginary. They're both still part of that system, that whole system. So number 3, if a number is an integer, then it is a whole number. We have our integers here. If it's an integer, then it is a whole number. So that can be always, sometimes, or never. Sometimes, right? We have 0, 1, 2, 0, 1, 2. So some of them are, if they're negative, they're not. Okay? So 0, 1 to infinity are positive numbers, are our whole numbers, so sometimes true. Number 4, if a number is a rational number, then it is an irrational number. Do these boxes touch each other? No, so what does that mean? Never true, right? You can't be rational and irrational, right? Those two things don't touch, they don't meet. Then number 5, if a number is an irrational number, then it is an integer. If a number is an irrational number, then it is an integer. So is that going to be, here's our irrational, here's our integers, do they touch? Are they inside one another? Nope, so never true. And then our last one, if a number is a natural number, then it is a rational number. So if a number is a natural number, so we're looking at our naturals, is it inside the rational box? Yes, so that is always true. Okay. Going on over to the next page. We're going to look at some properties of our real number system. So we're just looking at these. Okay, we're not dealing with imaginary. We're not dealing with a whole complex number system, just the real numbers. So we have our distributive property. I need to erase. Does anybody know what our distributive property is? Or how it works? You guys, really just the four of us, or six of us here. If you want to go to like each corner in these two middle rows, you guys can take the masks off. Be 6 feet apart. So if you stay there, she goes to that corner. You come up to like this corner. We're up a couple desks, but you guys can take
What
this.
street should I go up to?
If you go up to like that second one, that would be good. You go to that far. That'd be good. Right. So our distributive property. First, let's look at what it looks like. So if we had a number outside and a variable plus some other number. So this is how we would signify that we have our distributive property. We're going to take this value, we're going to distribute it to both. So we're going to multiply into the parentheses. That is going to get us 2x plus 4. So our distributive property, we distribute across parentheses or into parentheses. That's essentially what we're doing. We want to distribute into the parentheses. So here's our property down here at the bottom of the notes. Multiplication distributes across addition. So again, we have addition. Of course, it'll also distribute across subtraction as well. So if we had a negative, we would have 2x minus 4, which would just be the difference. Okay. So again, multiplication distributes across addition whenever we have those parentheses. Okay. So let's just do one of these. I think you guys remember that. So let's look at A. We have 3 times 2x. Minus 3, x minus 2y. Okay. So if we are to distribute, use our distributive property, what would be our first thing? What are we going to do on this one? Multiply. So that gets us 6x, the variable sticks with it, and then 3 times the negative 4 gets us negative 12y. Then we're going to do the same thing with this one. This is different though because we have that negative with it. That negative distributes with that 3. That negative is connected with that 3. We're going to have negative 3 times x. We're going to get us negative 3x. Negative 3 times negative 2 is going to get us a positive 6y. Okay, so that's our distributive property. Right? We're going to distribute across our addition or across our subtraction. You guys want to do another one? Or is that good? Again, this is your notes, so if you want me to do them all, I can. Or if you got it, we'll continue on. Okay, so here are some of the other properties that we're going to look at today. Okay. So we have the inverse property for addition is the sum of a number and its opposite is equal to 0. We have the inverse property of multiplication. Well, here, let's demonstrate that one. So the sum of a number and its opposite is equal to 0. So if we have 3, and its opposite would be a negative 3. Right? Opposite of 3 is negative 3. So if we add a negative 3, we get 0. So that's our inverse property of addition. You add something of a negative value, get 0. Then we have the inverse property for multiplication. So the product of a number, we have 4. And its reciprocal, does anybody remember what the reciprocal is? What would be the reciprocal of 4? 1/4. So we are flipping it across our divisor. And we're putting a 1 on top, so we're moving it to the denominator of our fraction. So 4 times 1/4 is going to give us the value of 1, so it's equal to 1. Our next property is the zero property of multiplication. The product of a number and 0 equals 0. So we have 5 times 0, we get 0. The distributive property we just did. Then we have our closure properties. So we have these two properties that we're going to look at. So we have the closure property of addition. So the sum of any two real numbers is another real number. So all that's saying is 3 plus 4 is equal to 7. Again, we're talking about the real numbers. So we could have real numbers that are decimals. We have 2.5 plus 0.5. It's going to give us 3. Okay. And then our closure property of multiplication, the product of two real numbers is another real number. So same thing, same idea as closure property of addition. Two real numbers multiplied together ends and results in another real number. Okay. Can't take a real number times a real number and end up with an imaginary number. Those are what those two properties are saying. Can't take two real numbers, add them together, and get an imaginary number. So on the next page, name the property illustrated in each statement. So what would be A? We have 4 times 0 equals 0. What property is illustrated on that? So which of these has a multiplication by 0? 0 property of multiplication, right? So the product of a number and 0 equals 0. That would be our 0 product multiplication. What about B? I'm trying to trick us on this one. 7 times 8 minus 3. But what did they do? They did 8 minus 3. So what does that fall under? What property does that fall under? 8 minus 3 equals 5. Or we can think about it this way. We have 8 minus 3. We're really adding a negative number. That gets us that 5. So what property would that fall under? Which property has to deal with sums? We have two real numbers, we sum them together, we get another real number. So what is that one? Closure property of addition, right? So we have 7 times 8 minus 3 equals 7 times 5. That 8 minus 3, even though it's subtraction, you're really just adding a negative number. So we get that 5. So that's still our closure property of addition. Letter C, we've got 4x plus 3 minus 4x equals 3. So it's no longer a closure product. What is this product doing? We have 4x minus 4x. What does that one look like? Which of these ends up with us getting a 0? So we have 4x minus 4x. Of course, we have that 3. But we're not worried about the 3. If we have 4x minus 4x, what does that end with? 0, right? So if we end up with a 0, the sum of a number and its opposite is equal to 0. So that's our inverse property for addition. Right? The 3 equals 3, that's fine. But again, what's happening is we're getting rid of that 4x. Okay. Then we have D. We have negative 2 times 3x plus 7 equals negative 6x minus 14. What property is that going to fall under? It's our distributive property. Very good. So again, we're distributing, right? We're multiplying across addition. So negative 2 times 3x gives us negative 6x. Negative 2 times 7 gives us negative 14. So our distributive property, and then E, we have 5x times 1/5 equals x. Right? You can kind of ignore the x's on this one. We have 5 times 1/5. What is that one going to be? Inverse property multiplication. Perfect. Okay. So those are the properties we've been dealing with for a very long time. Okay, we just sometimes forget our properties. But we've been doing those properties and we've been following our order of operations. Again, PEMDAS. What does our P stand for in PEMDAS? Parentheses. Right? Actually, they're trying to change it now. They're trying to call it GIMDAS for grouping. Because again, we don't just use parentheses anymore. We also have brackets. We also have division lines, right? So all these things are ways of grouping numbers. So they're trying to say for the P, right, it's more than just parentheses. We also have brackets. We also have division lines. So we want to group these things. So they're trying to change the P with the G. But I still think PEMDAS is easier to remember than GIMDAS. It just doesn't sound right. What about E? What does our E stand for? Exponents. Right. We have 3 squared. Right. So our exponents would be our next thing to do. Then we have our N and our D, which is our multiplication and division. Generally, we want to go from left to right. If there's no other way to do it. But you don't necessarily have to do that. You can also multiply and divide what things are going to cancel out to make things easier. But generally speaking, most people work from left to right. You don't have to. And then A and S are last operations. Addition and subtraction. Right? So those are our letters of PEMDAS and what they mean. So let's do a few of these. Pick a couple. Which ones do you want to do? Pick a few. What letter? E. Oh, B? Okay. We can do both. Okay, so B would be first. We got 16 minus 4 squared plus 12 divided by 6 times 2. Okay. So again, according to PEMDAS, we don't have any parentheses. We do have an exponent, so let's do that first. So if we have negative 4 squared, the only part of this that we're squaring is the 4. That negative actually just stays there. So we have 16 minus, well, 4 squared is 16. Okay. Everything else is kind of staying the same until we get to our next one, multiplication and division. Okay. So here's what I was saying. Normally we work left to right. We don't actually have to. So let's do it both ways. Okay, I'm going to split up the problem. If we do our division first, right? 12 divided by 6 is going to get us 2. And then we're going to multiply it by 2. Right? That's going to get us plus 4. If we did our multiplication first, we have 16 minus 16 plus, we have 12, 6 times 2. It's 12. What do we have? We get 1. So did that really work? What I was saying? You gotta go left to right. Okay. So we get 2 different numbers, we get 2 different answers. We do need to go left to right whenever they're out in order like that. So forget what I said earlier. We need to go left to right. Then we have 16 minus 16 plus 4. We get 4 left over. Right. What do we want to do next? You say E? Or did I just say E?
On D, would you just treat it like, because there's no number in the parentheses, so would you just treat it like that, there's like a 1 in front of the X?
So there's no number in the parentheses, right? So if there's no number in front of our variable, we just have a 1 in front of it. So yep, we have 1x. So we have that negative, though. That negative is going to distribute across our parentheses. 4x minus x plus 4. And again, we would combine our like terms in this one, right? We have x's here. We can combine those x's. That 4 is going to stay by itself. So we have 4x minus an x. So that is going to get us 3x plus 4. You guys want to do any others? You guys sticking out? All right, so that's it for the notes for today. This next page, we actually have all this on Schoology. So you guys can finish that on Schoology.